Hello Chem 203 students. Today we're going to perform the acid potentiometric titration. In the second experiment of the course, you have seen the acid-base titration where we have used a colored indicator. Today we're going to do an acid-base titration, but we are not going to use a colored indicator. Instead, we are going to use a pH meter equipment. First, we will start with the first part of the experiment with the strong acid titration. This is a pH meter containing a pH electrode. The pH electrode is stored in a KCl solution. This electrode, this KCl solution should not be thrown away. It should be kept in order to preserve the electrode. We will start first with preparing our solution, the acid solution. We have a 0.1 molar HCl. We should pipette 10 milliliter of this solution. We will pipette it inside the beaker. And we should add distilled water around 100 in order for the electrode later on to be immersed inside the solution. A small note, the pH meter here is used in order to monitor the acidity of the solution. So by using the pH meter in this experiment, we can see how the solution reaches its equivalence point without using a colored indicator. So the acid solution is ready. Now we're going to fill our burette with the titrant 0.1 molar NaOH. First, we have to clean our burette with small volume of distilled water. Then, with a small volume of the titrant NaOH, using a funnel, we add small volume of NaOH just to rinse the burette. Now we will fill our burette with the NaOH solution. You can see here that we have bubbles in the burette. So we have to remove the bottle before adjusting the meniscus. And here we are, no more bubbles in the burette. We remove the funnel and we adjust at 0. The meniscus must be tangent to 0. And here we are ready for titration. Okay, here we have to prepare our electrode. So as I said, this pH meter is used in order to control the acidity of our solution throughout the titration. We remove the electrode, we remove the cuvette of the electrode, and we keep it aside. And we have to clean the electrode each time before and after usage with distilled water and we have to wipe it with a tissue before using it. We insert a magnet bar inside our acid solution. We adjust the burette, and now we have to insert our electrode inside the beaker. Please note that the electrode must not touch the bottom or the side of the beaker, and it must be dipped around 1 centimeter inside the solution. We turn on the stirrer, and please be careful not for the magnet bar to touch the electrode. Now we will start our titration. Before starting adding NaOH, we have to record the pH of the solution without adding any NaOH. This means at V of NaOH equals 0, the pH will be 1.794. Now we will add at each time 0.5 milliliter of our NaOH solution. We count till 5 and we record the value of the pH. We start by adding the first 0.5. 1, 2, 3, 4, 5, 1.814. Again, at 1 milliliter volume NaOH, we have a pH of 1.833. We add another 0.5 milliliter. The pH 1.869. After adding successive 0.5 milliliter of NaOH, 8 milliliter will have a pH of 3.955. 8.5 milliliter. At 8.5 milliliter, we can see that there is a jump. The pH that was 3.955 has reached a 9.688 value. At 9, 10.419, 9.5, 10.716, for 10 milliliter NaOH, 11.029, 10.5, 11.276, 11 milliliter NaOH has a pH of 11.419. We keep adding at each time 0.5 milliliter of NaOH. And we record the value of the pH. We can notice that the value is changing slowly. At 11 range of pH, now we have reached a 16 volume milliliter of NaOH with a pH of 11.952. We can deduce that our solution has become acidic after passing the equivalence point, basic. So as soon as we reach a 12 value of pH, we can stop titrating. For 17 milliliter, we have reached a 12.013 pH. So we are done with the first part of the experiment. You can see the table of values for the first part of the experiment, strong acid titration. So using this table, you can plot the required graph. In part 2 of the experiment, we will perform weak acid titration with the same NaOH solution, 0.1 molar concentration, and using the pH meter. We will pipette. The weak acid we have is with an unknown concentration. We don't know the concentration. You have to deduce it later on from the graph. So we pipette (20 milliliter) of the weak acid with unknown concentration . We add distilled water at around 100 milliliter. Adding distilled water is just for the electrode to dip in the solution. The burette is ready with our titrant. The electrode has been cleaned after the first part and is ready to be used in the second part. We should not forget the magnet bar. We immerse our electrode inside the acidic solution. We turn on the stirrer. The same procedure as part 1. We will record the value of the pH of the acidic solution without adding any NaOH solution. It is 2.968, and we start adding 0.5 milliliter additions, and at each time we have to record the pH. At 0.5 we have a pH of 3.109. One milliliter of NaOH, 3.260. 1.5 milliliter, 3.392 pH value. For 2 milliliters, a value of 3.488. Adding again 0.5 milliliter NaOH for a total of 15 milliliter. We have a pH of 5.111. We keep adding at each time 0.5. And recording the value of pH. (16.5 milliliter of NaOH). We are still in the range of 5.405. Again, 17.5 milliliter of NaOH has a value of 5.618 of pH. (18 milliliter for a value of 5.742. (19 milliliter of NaOH, 6 point. So we can here notice that there is a jump of the pH. We should wait. (6.691). It seems that we must add more additions of NaOH, but we are near the jump of the equivalence point. For 19.5 milliliter, we can see here the jump from 6.691, now it has reached 8.298. We'll wait because the pH meter is changing rapidly until the value stop changing in this rate. For 19.5 milliliter NaOH, we have a pH of 765. So we can deduce that between 18 and 19.5, there is a jump. We continue adding NaOH, 20 milliliter. So the equivalence point has been reached during the jump. We keep adding NaOH until a pH of 12. At each time we add 0.5, we record. All these values will be used when you draw your graph in the report. And from your graph, you can calculate the concentration of the weak acid used. For 21.5 NaOH, we have a pH of 773. We keep adding. Now the pH is 11.175. For 23 milliliter NaOH, it is in the 11 range. We keep adding. So once we add 0.5 NaOH, you count until 5 and then directly you record the value of the pH. Now we have reached 26 milliliter of NaOH, having a pH of 11.713. We keep adding. 28 milliliter of NaOH. The pH is still in the 11 range, 11.887. Twenty-nine milliliter. I think this is the last addition. 30.5 milliliter NaOH, and here we have reached the 12 value of pH. Part 2 is done. This is the table of values for the weak acid titration. Using these values, you can plot the required graph in your report and deduce the concentration of the weak acid used. The last part of the experiment is the titration of an unknown solution of H3PO4 with the same NaOH solution. We will be pipetting 25 milliliter of unknown H3PO4 . We add water for the electrode to dip in the solution. We insert the magnetic bar. Same procedure as part 1 and part 2 will be done. In this experiment, we have to go slowly because the graph will show you 3 equivalence points. This means that you will have a 3 jump during the titration. For V0 of NaOH without adding NaOH, we have a pH of 1.863. The same additions will be done 0.5 at each time. At each time we add 0.5, we count till 5, and we record directly the value of pH. Two 0.5 milliliter of NaOH has a pH of 1.967. Again, another 0.5 milliliter addition. For 4 milliliter NaOH, a 2.043 pH is obtained. .5 pH has a value of 2.086. The pH here is changing slowly. 2.120 for 5 milliliter. We keep adding an NaOH. Seven milliliter NaOH. .266 value pH. We're still in the range of 2 as pH. Again, 9 milliliter NaOH, 2.481. .5 has a value of 2.567. We keep adding NaOH and recording the values until we see the first jump. We can see here that the value is changing rapidly at a 12.5 milliliter addition of NaOH. So we will wait. 4.260 pH at 12.5. These are the results for the third titration of unknown concentration of phosphoric acid with NaOH. Using these results, you can plot the curve and deduce the first equivalence point, the second, and as you know, the third one is negligible. So, according to the curve, you can notice the jump, the two jumps. And we are done with this experiment.